Hello everyone, and I'm sorry I didn't get to posting this video much earlier than I was supposed to, but I have finals coming up and I had to study for them. Anyways, now that I'm finished studying, I'm going to do this video a little bit differently. Now, I didn't get enough time to plan for this, and so this is going to be more on optimizations, making the code better. And by better, I mean we're actually going to optimize it a little bit. We're also going to do a little memory management. So the first thing is the world. Now, the world, it's fine. There's really nothing wrong with the way we're doing it. We're getting the full 60 frames per second. Well, you might be able to. Mine's not because I got the recorder going. But if we, increase the size, then it's going to start bogging down and the frame rate is just going to drop a little, if you notice there. And if we do some outrageous number, like you're never going to have a 512 by 512 world, it's not even going to load. 1 to 2 frames a second. Yeah, that looks fun. So we're gonna improve upon that. And there are multiple ways of doing this. Whether you are using like a quad tree or chunks, the way I'm going to be doing it is by using the camera position. And so when we use the camera position, we linearly render the tiles that are like right next to the camera. So we don't go throughout the whole world rendering like we do right now, and instead, with the camera's position, we render only the tiles that are nearby the camera. And we can start doing this by heading into the tile renderer. And we're going to be changing our render tile just a little bit. We're going to have a tile ID instead of a byte ID. Now, if you wish, you can change the name to tile. And that should be it for the tile renderer class. In the world class, there's going to be a lot of changing necessary. And the first change I'm going to be adding is a getter. So we'll create a public tile get tile at int x and int y. And this isn't going to be as straightforward as you might think it would be. So instead, we're going to be using a try. And we'll get over the reason soon. Now, try will return, and it'll be the same as this, except it'll be tile.tiles, and it's the same thing in setTile as we put here. And the reason why we're using a try and catch clause is because of the way we're rendering. So with the view, there's a slight, well, not a slight, there is a full-on possible chance that we're going to get an array out of bounds exception. So we're going to have to catch this and use array index out of bounds exception. Now, you don't have to print stack trace. You don't need to do that. All you got to do is return null, because we're going to handle this ourselves in the render method up here. So I'm going to comment this out, and I'm going to create a few variables. The first variable I'm just going to create up here, private final int. I'm going to call it view, and we'll set this to 6 for now. And down in the render method, we're going to create a couple of more. We're going to create a couple more variables here. Int position x, and this is going to be the center of the screen with the offset of our world. So we're going to cast this to an int here, and we're going to use cam get position dot x plus window get width divided by 2, and all of this divided by scale times 2. Oh, speaking of window, I thought I already did this. We're going to need a window variable passed into the render. And this is the exact reason why, because it's dead center of the window, and we offset that with the camera's position. And this should really be the same for position Y. Just change some things around. And one of the only differences in this equation here is that this is a minus, not plus, but minus. Now let's get into our for loop here. And I is going to be less than view. We'll create another one as well. And now comes for the tile. So we'll create a tile t, and that'll equal to get tile, and this will be I minus pos x and j plus pos y. And if this so happens to return null, well, then it's not going to run the next line of code because we have to test this. So if t is not equal to null, then we go with this line of code here, which is our tile renderer, which is render tile. We'll pass in t I minus pos x and negative j minus pos y. And so we'll pass in everything the same. And let's give this a test right after we pass in window. Oh, I forgot it's called win. I am renaming that to window so I don't make any further mistakes. Okay. Where did I go wrong? Okay, I'm back. So apparently it wants these in parentheses, which I managed to forget for some reason. So just put these in parentheses and you're ready to go. So why does it look like this? Well, remember that view variable that we created? Yeah, this controls the amount of tiles that are shown on the screen. So my value would be 24, and this should render everything. So now let's do something like 128 by 128, for example. And look at that. No frame rate drop. Full on 60 frames per second. Now let's go with something completely outrageous real fast just to test things out. And that's 1024 by 1024. This is just to see if it works. Look at that, 60 frames per second. And we're not lagging. Now I'm not gonna go all the way down to the bottom right because that's gonna take forever. I'm gonna go back with 64 by 64. Okay. I guess it's safe to get rid of that now. Now comes for clearing memory after we delete a model or a shader or a texture, because maybe you don't want this texture to be loaded, but you're still running the game, and now you have to delete this texture. It's doing nothing. It's just taking up room. This is easy. We just need a protected void finalize here, and this will override the existing object finalize here. All we need to do now is make sure I have everything important. Yep. All we need to do now is GL delete textures and our ID for the texture. So this should delete our texture when we don't need it anymore. Okay, so I made a slight mistake during recording that video, and note to self, don't record a video after a study session. Okay, so the mistake was the finalize method right here, and I did this throughout the last few, so make sure you do the same thing with all the rest of them here. And finalize should be throwing, so it should throws throwable. So finalize should throws throwable right there. And we must call super.finalize at the end. This way, in case of anything else, it will clear every other variable that may have been created by this class. So it'll get rid of width and height for us if we did it like this, whereas we'd still have ID and width if we didn't do this. We'd still have ID, height, and width if we didn't do it like this. So make sure you have throws throwable at the end of finalize, much like this, and super.finalize at the end of the method. What about for the other things like the shader and the model? Well, let me go with model first. And it's actually really simple. All we need to do is do the same thing. Oops. Protected void finalize. And we use GL delete buffers. We'll delete VID, TID, and IID. So this should delete every bit of information this has. So Now for the texture, or not the texture, now for the shader. Boy. And it's going to be the same thing. The finalize, and instead we need to detach the shaders. So GL detach shader from program, and what was it called? VS. We need to do the same thing with FS. Now we can delete the shader. So we'll delete both of them, VS and FS, with GL delete shader. And last but not least, GL delete program. And we'll pass in program. Now this should get rid of our shader. So that should be pretty much it for deleting our stuff. I mean, that's pretty much it for deleting our stuff. And last but not least, the camera. Now, I've been informed on an issue over on GitHub that while this is alright, it's better to use something else. So, the way we have this set up, we're allocating things like twice. We're allocating a new target, we're allocating a new position, when really we don't even need these two. We don't even need them to. So I'm just going to get rid of everything in Get Projection, and I'm just going to put in return projection dot translate with our position and a new matrix for F for a target. That's pretty much it. All of what we did simplified on one line of code right there. Talk about optimization. So that should pretty much be it for this video. We fixed a few things. We optimized the camera, and we added deletion code for the model, shader, and texture. Hopefully next time I record a video, it'll definitely be on the player. We'll be getting into entities and having fun with all that stuff. So, I hope to see you in that video.